So OSPF works in
Layer 3.
layer 3. Okay, see why this OSPF is much popular, guys. Before we getting into the actual OSPF, the handshake process, or not handshake process, the neighborship process. Okay, so we already saw the differences between the static route and the dynamic routing, correct? So what is the
Yeah.
difference between static and dynamic route, Avinash? Avinash,
Static route will be configuring configuration manually, Anna.
what manually configuration?
We'll be putting static routes and manually
E-
in.
I gave you one word. Okay, what is that I gave you when it comes to the static route and when it comes to dynamic routing? Tell me, Avinash.
Anna, exactly, I don't know the word, Anna,
What is
but
that?
I know what the
నేను
process is.
రాశాను కదా. See, Rachit, what did you wrote for static route? I think I asked you this multiple times.
Yeah, static routing, we configure manually the routing table.
Correct.
And dynamically, it is build routing table dynamically with the help of routing protocol.
Hmm. అవినాష్ ఇది
RIP
రాయమని చెప్పానా
OSPF.
లేదా?
నా మెన్షన్ చేసుకున్నాను అన్న.
See, if you answer it like this, right, definitely you will get caught. That's why you're not got selected for Dell. If you repeat the same mistakes. See, first of all, I'm not a fool, okay, to give you the what are the questions and how you have to answer and all. Because if you answer like what I'm trying to say, there will be no cross questions they will ask you. They'll ask you simply, they'll ask you, okay, what is manually configuring? Then you will get stuck. But if you say at the first time, so static route is something the routing table is manually configured. And dynamic routing is something like the routing table is updated dynamically with the help of the routing protocols like RIP or OSPF or EIGRP. See how good is this answer is. This is the key points. This is what they'll look into it. And still, if you're not focusing, I can't do anything. Okay, so let's get into started. So why OSPF? See, why I specifically talking about the OSPF? Why OSPF makes so popular when it comes to the other routing protocols? So what are the other routing protocols we have? See, this routing protocol. Can you see my screen? No, right? 1 minute. Let me share my screen. Okay, see, we have, let's see some basic differences. OSPF. See, okay, first of all, we have a static route and dynamic routing. See, what are the protocols comes under dynamic routing? Everyone, Abdul, what are the protocols comes under dynamic routing?
RIP.
Hmm?
RIP.
Okay.
OSPF.
Okay.
EIGRP.
Okay.
BGP.
BGP. Okay. Next. Okay. See, this is dynamic routing protocol, which has been divided like this. Okay. So what are the protocols which I've talking about it, right? These are called as a IGP, interior gateway protocols. This is EGP, exterior gateway protocols. Exterior gateway protocols, we have only BGP. See, what do you mean by IGP and what do you mean by EGP? So IGP is Interior Gateway Protocols. Under IGP, it falls under 3 protocols: RIP, OSPF, EIGRP, and you also have ISIS as well. Okay, these are the 4 protocols which falls under this. Okay, and we have EGP. Under EGP, we have only BGP. So what do you mean by IGP?
External Gateway Protocol.
Interior Gateway Protocol, IGP, sorry. EGP is Exterior Gateway Protocol.
What is that EGP and IGP?
IGP is nothing but all the protocols which is governed by a single administrative.
See,
single-
see, guys, look at this architecture. Very, very important.
And EGP is the protocols which will be communicating between different 2 A's. That is different between different autonomous systems.
Wait.
Correct? Huh?
Rachit?
Yes, sir.
So in your organization, you're using T1, T2 lines, correct?
Yes, sir.
Okay. So where these T1, T2 lines are being used? See, guys, before this, I want to tell you about LAN and WAN. So LAN is something local area network. Okay, WAN is wide area network. Okay. So LAN means inside the organization, WAN, which is used to connect to the external networks. Okay. For example, if you have 2 buildings, okay, so this is building A and this is building B. Okay. Okay. If you want to do wiring inside your building A, right, that is a LAN topologies. Okay. So that is what we discussed earlier, like a star topology, bus topology, okay, or a mesh and full mesh, all this topology will come. So, and if you want to connect from building A to building B, right, there should be a WAN protocols will be working on it. A WAN technology will be using it. Okay. So in that WAN technologies, T1, T2. Yes, Rachit, am I right or not? See, T1, T2
Yes.
are the kind of lines, T1, T2, or I can say cables. Yes? No?
Yes, sir.
Okay.
Yes, sir.
Now tell me, Rachit. See, Rachit is working in an organization, so is most of the work on a T1, T2. He used to manage these 2 lines, correct? Yes.
Yes, Satya. Basically, ticket creation, calling
Mhm.
customer,
Okay.
and calling OKG. Yeah.
So where these T1, T2 lines are being used? Have you come across all these things? Okay, when you are in an organization, basically, you know what you mean by T1, T2 lines, right? Or yes or no?
No, no.
No, I'm not talking about you, Avinash. Wait. No
It
problem.
is
Yeah.
developed by AT&T company. I remember AT&T
ISP.
vendor.
Correct.
Yeah, and
It's provided by ISP. Okay.
yeah, it's a carrier system. I mean, it
Correct.
carries
Correct.
data and everything,
Right. But I
and
want to
basically
know.
used in
uh,
multiplex telephone calls like
okay.
internet and phone calls.
What is that in multiplex? Something you said.
Telephone calls,
Okay. No. Before that, you said
yeah, multiplexed telephone calls.
multiple telephone calls. Okay, that's it. So what exactly T1, T2? It is a cable. It is a cable.
Yeah, it's a cable.
It's a cable, right? So
Copper wired cable.
correct. Okay, yeah, that is what I want to know. Guys, now you understand what do you mean by T1, T2? I'll come to the routing part. Okay, you don't worry. I'll take you to the routing part. So T1, T2 is nothing but a cables, okay, which is managed by your ISPs. So Rachit said AT&T, right? Yes. AT&T people is going to provide you the T1, T2 cables. I mean, see, don't say if someone ask you AT&T. No, ISP is going to provide the T1, T2 cables. Okay, to connect to to connect to to connect to the branches from one branch office to another branch office. They can go via T1, T2 or Metro Ethernet line or MPLS connection. That's fine. So now, what exactly we are talking? See, this can be a T1, T2 line. This can be an MPLS connection or internet line. Okay. Yeah. Okay.
Satya, one doubt. T1, T2 means it is really a virtual cable or a
No,
physical cable?
that is what I want you to understand, right? So it's a copper cable. It's not a virtual cable. It's a physical cable. Okay. It's a physical cable. Okay. So we have some routing protocols like IGP and EGP. So IGP, interior gateway routing protocols. So this interior gateway routing protocols, which is something used in the inside the autonomous system. What do you mean by autonomous system? I think yesterday I asked you to find out, right?
Yeah, it is a group of group of networks governed by a single administrator.
Group of networks. Okay.
Like different example, shall I give? Suppose if we are having one organization and we have different
Correct. See, it's an
branches,
autonomous
and it is
system. It's like a collection of networks. Okay.
Yeah.
Autonomous system is nothing but a collection of networks managed by a single administration. Single administration. So they have every organization, they have own AS number. For example, let's take it. This is a TCS office, and this is a this is a HCL office. Okay. So every organization, they have their own autonomous system number. Okay. So they will purchase this autonomous system number. Okay. So, and under this autonomous system number, who is managing all these things? TCS is managing, right? Similarly, so that is what your autonomous system is telling you. Autonomous system number, which is a collection of networks managed by the single administration. Okay. So every organization have their own autonomous system number. Now, inside the autonomous system, okay, inside the autonomous system, either they can use RIP, OSPF, EIGRP, and ISIS. Our focus is on OSPF. Why we are not using these things, we'll discuss that in some time. So if you want to connect one autonomous system to another autonomous system, that is exterior. Okay. So in this case, you will use BGP. All right, guys. Any questions so far? Any questions?
No, Satya. No,
All
Satya.
clear? So IGP protocols, which is something which is used inside the autonomous system inside the autonomous system. Okay. EGP, if you want to connect one AS to another AS, then EGP is used. Under the EGP, what are the protocols we have? Only one protocol, that is called BGP. Now let's come back to the LAN protocols. See, what are the LAN protocols we have? LAN protocols, LAN routing protocols.
VLANs.
LAN routing protocols, what do you say? LAN side routing protocols. See guys, this is your LAN. Okay. This is your WAN. See, now tell me what is the LAN side routing protocols? EIGRP, OSPF, REP, and WAN side protocols. Rashid?
BGP.
BGP. Okay. See, inside the LAN, so we have 4 different protocols like EIGRP, OSPF, and ISIS. ISIS is something which is not using it. Okay. So, but you know, yeah.
Is switching VLAN, those kind which comes in layer 2.
EIGRP, OSPF, and REP. Guys, can you hear me, right?
Yeah.
Okay. Yeah. First, we have a RIP protocol. EIGRP, and then OSPF. See guys, all these three things do the same job. So what do you mean by same job? You used to dynamically build the routing table. Okay. So under the routing, right? So we discussed about IGP and EGP. Okay. Now we have under routing, we have distance vector and a link state. I'll tell you under distance vector, so RIP and EIGRP will coming into place. Under link state, OSPF will be placing. Okay, so I'll tell you what is the distance vector, okay, and link state routing protocol. So far, any questions?
No, sir.
Okay, so distance vector, right? So we have two protocols. What are those two protocols? RIP and EIGRP. Okay. See, there is so many differences is there between those two, but I'll share one common difference. Okay. Maybe like two differences which I will share it. Okay. So in distance vector, right? One minute. One minute, guys. So when you use distance vector routing protocol, right, like RIP or OSPF, sorry, RIP or EIGRP. Okay. So what will happen when you use distance routing protocol? So there will be a routing table. So what is the command to check the routing table?
Show IP route.
Show IP route.
Show IP route. Okay.
Yes.
So what does the distance routing protocol will do? It sends the entire routing table. Okay. So what the distance, it sends entire routing table. Please make a note of it, guys. To directly connected neighbors. So what will be there inside the routing table, guys? So distance vector. So what does it do? It sends the entire routing table to directly connected neighbors. Okay. So what will be there inside the routing table? Rachit?
Destination,
Yeah,
subnet
correct.
mask.
See, entire
next
routing
hop.
table. Yeah. Okay, fine. So entire routing table will be sent from R1 to R2 if you use distance vector routing protocol. But link state routing protocol, right? It's not like that. So what does the link state routing protocol will do? It sends the information about the directly connected, it sends the information who are all the neighbors connected to this router. Okay, see, for this one, there is an R3. So when you use link state routing protocol, right? See, R2 is forming a neighborship with R1, and R2, it's going to send information. Okay, it's going to send about the connected links. See, for this R2, R3 is connected. So the R2 will tell to the R1, R3 is connected to me. So link state routing protocol, which tells about the directly connected links. So R3 is my directly connected link. It's going to send that information to R1. Whereas in distance vector routing protocol, right, it's not like that. It's going to send the entire routing table to R2. But in link state routing protocol, it sends the only link information. So it sends only directly connected links. It shares, or it sends only directly connected links information. Directly connected link information.
What it will carry such a link information?
Very good question. So what does the link is going to see? This is a link, right? So it's going to carry the prefix information. So what is the prefix? Prefix is nothing but the IP address. Okay. And the link information is there, right? In that link information, there will be a prefix information. Prefix means what type of subnet is being carried and what type of network. Okay. So which means it's a point-to-point connection or a broadcast or non-broadcast. This type of information we will be carrying to the R3 to R2. So that is what it is. Okay, so when it comes to the link state routing protocol, it sends only the link information. It won't send the entire routing table. Okay, whereas in distance vector routing table, it sends the entire routing table. This is the major difference between the distance vector and link state. If you want, I will repeat it again. See, I told you dynamic routing protocols, we have IGP and EGP. IGP, RIP, OSPF, EIGRP, EGP, we have only BGP. Okay, so in dynamic routing protocols, in IGP is something which is used inside the autonomous system. Okay, we have inside the autonomous system, either we can use distance vector or link state. Distance vector, what are the protocols will come, like RIP and OSPF, and link state routing protocols, so what are the information will come? Only the distance vector, we have RIP and EIGRP, and link state, we have OSPF. When you use distance vector routing protocol, right? So what will happen? It will send the entire routing table to directly connected neighbors. Okay. When you use link state routing protocol, right? It sends the information. Okay. So the link state protocols like OSPF, it sends the information about the directly connected links to all the routers. For example, if you have a R2, right? So R2, I'm directly connected to you. So it will send the link information, and also who are all the neighbors connected to me, directly connected links, that is also sent to this guy. Okay. Any questions? Any questions on this one? Okay. And they'll ask, and RIP. See, why we are going with RIP, PIG, RP, and OSPF. See, RIP, right? For example, if you have only 15 routers, so RIP can support only, so we talk about dynamic routing protocols. Dynamic routing protocols means which something manually build the routing table, correct? See, when you're configuring the RIP protocol, right? RIP protocol, the disadvantage of RIP is it supports only 15 hop count, which means that if you have 15 routers, that's it. If you have 20 routers, then RIP is not suitable. Okay, so RIP only supports 15 hop count, which means supports only 15 routers. In your organization, if you have like 30 routers, then you cannot configure RIP, because why? RIP supports only 15 route 15 routers or 15. See, hops, you should say hops, HOP. Okay, any questions? And EIGRP, OSPF. Okay, EIGRP, if you talk about, right, EIGRP is a Cisco proprietary, OSPF is an open standard. That is a challenging thing, because EIGRP can only configure on Cisco routers and switches. OSPF is not like that. OSPF can run on any devices, on any vendors. Okay, so that is why inside the autonomous system, the widely routing protocol which is being used, that is OSPF. Okay, so RIP, which supports only 15 hop counts. Okay, EIGRP is a Cisco proprietary, it cannot run on all the devices, whereas OSPF, it's an open standard protocol. It's an open standard protocol, can be run on all the vendors. Any questions? Any questions, guys? Hmm?
Sector?
What?
Any ops is there, like how many routers it can scale
Where?
while routing for
Where?
OSPF?
OSPF, no. Unlimited hop count. Okay. Any other question?
I mean, in local area network, RIP is used, Satya.
No, in local area network, we mostly use OSPF only in the inside the LAN.
I mean, there are less routers now, so I thought.
Yeah, even though if you have a less routers, right? But but still the RIP is an old protocol. Even in new CCNA topics, they're removed RIP.
Okay.
Okay. Because most of the organization, they have so many multi-layer switches and all. Okay, they should go with at least minimum 50 to 60 devices will be there. So RIP is very widely range, very. I think they're not using it. They're not using. Either they'll go with a static route or OSPF.
Okay.
Even AGRP also, it cannot be run on all the machines. Only it can run on the Cisco
Cisco
devices.
proprietary.
Cisco, only Cisco devices. Any questions? Anyone? Ashwini?
Yes, sir.
Any questions?
No, sir.
Okay. So let's talk about more into OSPF. Now we came across some challenges in RIP, and we came across some challenges in EIGRP. So what are those challenges? Anyone can say?
In RIP, it supports only 15 routers. That is, it is not scalable beyond more than 15 routers. And EIGRP does not support for any other device. It is only Cisco proprietary.
Mm-hmm.
And OSPF, when OSPF comes, it is open standard and it can run on all the devices, and it can route more than any number of routers it
It
can
supports.
scale.
See. Don't
Yeah,
frame your own sentences. Okay. So when you frame technical sentences. So RIP supports maximum of 15 hop count. EAGRP is a Cisco proprietary, cannot run on all the vendors. Okay. And OSPF supports unlimited hop count. It's an open standard protocol, can run on all the machines, all the vendors. Simple. Okay. So give the simple and straightforward answers. Okay. Let's talk about more on OSPF. Okay. See, when it comes, okay, I told you about OSPF. It's a link state routing protocol. Okay, this is R1 and this is R2. So yesterday we saw the configuration, right? So how to do the OSPF configuration? It's very simple. Config / router OSPF 1. Okay, and network. See, what did I told you? So what are the prefixes that you want to advertise on R1? You're going to write it that, and followed by wildcard mask and followed by area. See, yeah, I'll discuss about this area. See, OSPF has divided into multiple areas. Okay. See, OSPF. Okay. See, you have one organization. Okay. You have, like a 10,000 employees. 10,000 employees will be, it's just a very minimum 10,000 employees are there. And you want to build such a large network, and you have OSPF is suitable for that one inside your campus or inside your LAN. When you're building such type of things, right? Okay. And at least you should have like, let's take it, you should have 200 routers. How many routers you should have? You should require 200 routers. Okay, so the problem with OSPF, guys, the problem with OSPF is a link state routing protocol. And one more thing I want to tell you, OSPF uses which are, okay, OSPF uses a link state algorithm, guys. I think that is Dijkstra algorithm. Okay, so I'll tell you. So see, OSPF, when you configure the OSPF, right, there will be multiple areas. If you have more routers, let's take it, if you have 200 routers, right, every routers cannot be put it in the area, in single area. By default, we have an area 0. See, guys, we have area 0 in OSPF that is called as a backbone area. Okay, area 0 in OSPF that is called as a backbone area. Okay, now see, if you have a 200 routers, okay, if you have a 200 routers, and if you put all the 200 routers inside the area 0, right? Okay, okay. Now, before we discussing about this one, can you tell me why we are doing the VLAN? You know about the VLANs, right? Everyone, if you understand the VLAN concept, this areas also will be easily get understand. Why do we are using VLANs? Hey, please tell me here. It's a shame to me if you're not telling this. Why do we need VLANs?
Dividing
To reduce
one broadcast domain into multiple broadcast domains.
To reduce the number of broadcast. Okay, that's why we're creating the VLANs, correct? Yes or no?
Yes, sir.
So by doing this, what are we achieving? Less number of broadcast and bandwidth also is saving. Okay. Okay. So even in areas, right, if you have a 200 routers, if you're putting in a single area, right? So what will happen? See, so what did I told about OSPF difference between the distance vector and link state, right? So link state router, so what does it do? Okay, it's going to send the prefix information to its neighbors, okay, which is sending, okay, if you have 1.1.1.1, okay, which is connected here, okay, so you're advertising to this guy, and this guy will advertise to this guy, this guy will advertise to this guy, like this, like this, like this. Okay, it will keep on going on everywhere. So there is some router, you have configured new prefix or new subnet in this range. Let's take it 4.4.4.4. When you add this new prefix and your OSPF has to advertise this new prefix to all the 200 routers, then if you can ask me, what is the problem in that? If you're adding a new prefix to the subnet, okay, it's going to update to all the neighbors. So what will happen when you have a switch, the ARP request is sending to all the ports on the switch, what will happen? It's in a, if you have 48 ports, right, the ARP request will go to all the 48 ports. Okay. Similarly, here as well, what will happen? The request if you have a new prefix, okay, if you want to advertise into OSPF domain, right? So that OSPF will forward to all the routers, 200. So that is not a problem. But what is the problem here? OSPF, okay, see guys, in the routing table, we have when OSPF becomes neighbor, right? So there is 3 tables in the route, in all OSPF, that is called as a neighbor table, adjacency table, and routing table. Neighbor table means, for example, if R1 is connected to R2, okay, so for my R2, who is my neighbor? R1. So in my R2 neighbor table, I have this R1 route. For example, see, this is my neighbor table. In my neighbor table, right? In my neighbor table, so who I have 1.1.2, and here I have neighbor table. Who is my neighbor? 1.1.1.1. Okay, that is what it is. And what will happen? Every routers will be having their own neighbor table. So neighbor table, who are the neighbors who are directly connected? That information will be there. I will show you in the lab now in some time. So what will happen? Even that is also not from adjacency table is nothing but what are the connected routes. Okay, for example, if this guy sends some information, okay, this guy's is adding some prefix information, like let's take it 192. Okay, so that prefixes has been advertised, so that will falls under the adjacency table. And then routing table. Routing table, what will happen now? Routing table, so this is what it is. In order to build this routing table, right? So OSPF, in order to build this routing table, so it's going to do the calculations. What calculations? Based on the cost, based on the metric. Based on the metric, it's going to build the routing table. Okay, so what is the metric? Cost. So it's going to run the SPF algorithm on all the devices. See, if they'll ask you what is the use of dividing the OSPF areas. Okay, so if there is any update, if there is any changes happen, right? So the changes should affect to all the changes will reach to all the routers inside the OSPF domain. Because of this, there'll be too much of bandwidth utilization, too much of traffic will be there, and also more than very important, the SPF calculation will take a lot of time. See, to make the best route and put it in the routing table, right? So what is the metric we are using to calculate the best route, which for OSPF is, which is SPF algorithm. So because of that, if you have 200 routers, every routers has to calculate the SPF. It takes a lot of time. It takes a huge amount of time to put the route in the routing table. So that is why we are dividing the one area into multiple areas. In every area, right, there is a limitation for OSPF. In every area, there should not be not more than 50 routers. Understand or not? Rachit?
Understood.
Rachit?
You only mention only more than 15 areas, less than 15 areas.
Huh?
More than 15 routers now.
Less than 50. I mean, see, not more than.
Okay.
Understand what I'm trying to say. Not more than 50 routers now. Only it supports a single area. See, you can have 50 or 100 areas. That is not a problem. Okay. But one area should be 50 routers. That's it.
Okay.
Not more than 50 routers.
Okay.
Okay. See, why we are dividing the OSPF into multiple areas? Nah? The concept is like there will be too much of traffic, okay, to reduce the number of LSS, or it takes lot of time for the SPF calculation. I will write it down. Why OSP to reduce the number of LSS takes time for SPF calculation. Shortest path, that's the SPF means shortest path calculation. That is nothing but the algorithm, digital algorithm, because it has to run on all the devices, right? So that's why it will take a lot of time. So to avoid these two things, that's why we are creating the OSPF into multiple areas. Any questions now? Simple. I just told you why OSPF is dividing into multiple areas now. The thing is like to reduce the number of LSS. LSS, link state advertisements. I will tell you what do you mean by LSS and all in some time. And it takes a lot of time for the SPF calculation for finding the best path or for finding the best route. Okay. Any questions now? Any questions, guys? Any questions? Okay. See, let's see the OSPF neighborship process, how the neighborship is being established. See, what are the commands to make the OSPF to come up? Router, OSPF, 1, and then what is the command? Network. What are the prefix you want to advertise? Wildcard mask, and followed by area. So by default, all the routers will be in area 0. Okay. By default, all the routers will be in area 0. Fine. Now let's look into this. Okay, see guys, yesterday I didn't save this. /0. Okay, see guys, now I'm gonna configure the OSPF. I'm going to run the Wireshark capture to show you at the packet level what is exactly is happening. Okay, and also I will capture some events. Debug IP OSPF. Okay, so I'll go to the config mode, router OSPF process ID. Okay, process ID is used to identify the OSPF process. Okay. Now, so what did I told you, Rachit? After OSPF, what is the next command?
OSPF.
Router OSPF1. After that, you have to advertise the prefixes, right? So on R1, so what are the prefixes I'm advertising? Or on R1, what are the prefixes I have to advertise?
Network.
No, I'm asking you. So don't forget about the command. On R1, so what are the routes or what are the prefixes I have to advertise?
1.1.1.1.
1.1.1.0, 0.0.0.0.255, area 0. And what is the one more prefix that I have to advertise? 192.168.1.0.0.0.255 area 0. Perfect. Similarly, on R2, Abdul, what are the prefixes I have to advertise?
Can't see the screen on backside. Router 2.
Router 2.
Okay. 1.1.1.0.
1.1.1.0.0.0.255 area 0. Okay. And 2.2.2.0.0.0.255 area 0. Okay. Similarly, on R3, 2 network and 3 network, 191. 192.168. Router OSPF
1.
network 2.2.2.0
area 0.
okay
2.0 0 and
okay now we're gonna talk about all these things right now. Okay, and you can also see in the white shark capture. See guys, I'm trying to establish the OSPF between R1 and R1 and R2 and R3. Between see, the neighborship will be formed between R1 and R2, and R2 to R1 will be formed. Okay, and R2 to R3. Now let's see how this roots is going to be get exchanged. Okay, first let's talk about the neighborship. See, when you configure the OSPF, right, with the help of network command. Okay, so I gave you the network command, right? See, carefully listen guys, if you want to make a note of it. When you configure the OSPF with the help of network command, so what will happen? Automatically your OSPF starts sending the LSA information. That is called as a type 1 LSA. You might have heard about it, the OSPF LSS and all, but we have a separate session. We'll discuss about the LSS later. But when you configure the OSPF, right, with the help of network command, right? So what will happen? OSPF starts sending the LSA. That is called as a type 1 LSA. Okay, so but anyhow, we are not discussing about the LSA now. We are discussing about the OSPF neighborship between R1 and R2. So what is the R1 router IP address here? This interface is 1.1.1. We are trying to establish a neighborship between R1 and R2. So when you configure the OSPF, right? So first OSPF sends the hello message. Okay. So first of all, see, OSPF has to go with the 7 states to build the neighborship. Okay. For neighborship, right? See that for neighborship states, first of all, it will go in down state, init state, okay, two-way state, xstart, exchange, loading, and full. We'll discuss these things today. Okay, so when you configure the OSPF, right, with the help of network command, so first of all, both the routers will be in a down state. So when you configure the OSPF with the network command, right, automatically your R1 will send the hello message, okay, to the R2. Since R1 and R2 doesn't know, see, R1 doesn't know about R2 and R2 also doesn't know about R1. So that's why both the routers will be in a down state first of all. But when you send the, when you send the hello message, right, hello message will be sending it with a multicast address of 224.0.0.5. See, and what is the hello message consist of? Let's see what is the hello message is there. So this is the OSPF hello packet. Inside the OSPF hello packet, right? So what is the what are the things we have? We have a subnet mask, okay, hello interval, See, we have a subnet mask hello in interval. Okay, hello interval means so the hello package will be keep sending for every 10 seconds. Okay. And then we have yeah. So this information, area ID, authentication. If authentication is configured, okay. Actually, there will be hello interval. There will be a dead interval also will be there. Area ID. When you send the OSPF hello packet, right? The hello packet contains version. Okay, see, these few things are very important. So those things only I'm telling you. Version will be there. Area ID will be there. Authentication, subnet mask, hello interval, and dead interval. Dead interval. See, dead interval. These are the informations will be there. Actually, you should supposed to say all, but I'm just telling you what are the main information has to be tell. So when you send the hello packet, right? Hello packets are keep exchanged between multicast IP address, which is 224.0.0.5. So when you configure the OSPF with the help of network command, right, automatically the OSPF send the hello message. Since R1, R2 doesn't know about the peer routers. Peer routers means R1 doesn't know about R2, R2 doesn't know about R1. Okay, so that's why both the routers initially will be in a down state. Okay, so when you send the hello message, right? Hello message contains this subnet mask, hello interval, dead interval, area ID, subnet, authentication. These are very, very important. And these parameters should match. Even, okay, these are the parameters should match. And there are some parameters which should not match that I will tell you later. Okay. So when you configure the OSPF, right? So first of all, both the routers will be downstate. Hello message will be sent. Hello message which contains all this information. Now R1 send the hello message and R2 also send the hello message. Fine. So since R1 doesn't know about R2 and R2 doesn't know about R2, so that's why both are in down state. Okay. Now initialization state. What will happen? Now R2 receives the hello message and now R1 send the hello message, R2 receives the hello message. So inside the hello message, right, what is there? So you see all this information and also there will be a router ID. Okay, so if you look into this one, right, see. Okay, you can see this, actually you can see the IP address, okay, IP address of R1. Okay, so when you send the hello message, right, there will be an IP address of R1. What is the R1 IP address, which is 1.1.1? So R1 send the hello message, which contains the IP address of R1, right? So first of all, both will be in down state. After down state, initialization state. In initialization state, what will happen? Once the R2 receives the hello packet, right? It contains all this information and also has the IP address of R1. So it put that information in the neighbor table. There will be a neighbor table, right? So who is my directly connected? See, that is what I told you, right? So it puts that information in the neighboring table. Who is my neighbor? 1.1.1 is my neighbor. And here also there will be neighbor table. Who is my neighbor? 1.1.1.2. I'm repeating it again. So when you configure the OSPF with the help of network command, right? So first OSPF sends the hello message. So hello message contains subnet mask, hello interval, dead interval, area ID, authentication, router ID, don't say router ID, or identification or IP address of router 1. Okay, IP address of R1. Okay, and similarly R2 also send the hello message. So both the routers will be downstate because both the routers not known of peer routers. That's why both are in downstate. Now initialization state. What will happen in initialization state? Now both the routers sends the hello messages and they are not recognized each other. Okay, so here R2 receives the hello message and puts the IP address inside the router. R2 receives the hello message and puts the prefix which came from the R1, put it in the routing table, sorry, neighbor table. Similarly, R2 sends the hello message, right? R1 receives the hello message and put the IP address of R2 inside the neighbor table now, but still both are not recognized each other. Okay. Now here, what will happen next is two-way state. In two-way state, right? Both the routers send and receive the hello message and both are recognized each other. Okay. So in two-way state, what will happen? Okay, so both the routers send and receive the hello message and both are recognized each other. Okay, any questions as of now? From here onwards, it will be little complicated. If you're not understand anything, just please stop me. I'll explain. If you understand, then I'll proceed. Meghla, Rachit, Ashwini, Avinash, Naveen. Hello.
Yes, Satya.
Okay, so what we are discussing, see, OSPF is trying to establish the neighborship between the R1 and R2. Okay, so when you configure the OSPF, right, what is happening at the backend, that is what we are discussing it. Okay, so Rachit, you're able to follow?
Yes, Satya.
Okay, see, I'm repeating it again. So when you configure the OSPF between R1 and R2, right, so the neighborship has to be get established between R1 and R2. If you want to establish the neighborship, right, there will be some few parameters is going to be get exchanged. That is what I'm discussing it right now. It has to go through the 7 states. So first will be the down state. When you configure the OSPF with the help of the network command, right? Okay, so it starts sending the hello message. Hello message contains some few parameters. Okay, so I told you those two parameters. Okay, so R1 sends the hello message. R1 sends the hello message to R2, and R2 sends the hello message to R1. Since both the routers not known each of us, that's why both are in a down state. Okay, and next initialization state. Now both the routers receives the hello message from its peers. Okay, and puts the entry in the neighbor table. So that will happen in the initialization state. And in two-way state, both the routers are recognized each other's. How they recognized? Because they're gonna see for this router. Okay, for this router, my neighboring ID is this one. Okay, so even R1, who is my router, who is my neighbor router, this guy. So now both are recognized each other. Okay, both are recognized. That's why it's a two-way state. In two-way state, now both are recognized each other. Both the routers are recognized each other, and they'll be seeing their own router ID information. Okay. Any questions? Now here onwards, the complication will be happen. There'll be an extart state. Okay. One thing which I didn't tell you, okay, in OSPF, okay, if you have in OSPF, all the routers, okay, in OSPF, all the routers should have the same database. If you have 100 routers, all the 100 routers inside the single area should have the same database. Okay, if you have 5 areas now, area 0, area, for example, where is my pen? Please keep that in mind. See, now R1, see, R1, R2, R3 are in area 0. Okay, all these 3 routers will be having the same database. If you want, I will show you now. See, show IP OSPF database. Okay, see this one here. We have now let's look into the R2 database. Okay, see 2.2.1. Okay, advertising router 2221. Okay, they forget about the sequence number and checksum, that will be keep verifying it, but you should see the link ID and advertising router. If you see this one here, right, the same thing will be there. Is it matching or not, guys? Can you see this or not? Hello?
Yes, sir.
Yes, sir.
Okay, so every router inside the OSPF domain should have the same database. Okay, So now for example, there is a one more, this is area 0, this is area 1, and this is area 2. Okay, you have 4 routers, and you have 1, 2, 3, 3 routers, and this is a area botted router, area 0. So here these routers will have same database. This routers will have same database. Okay, but if you cannot compare this router and this router should have the same database, no. So what I'm trying to say, all the routers should have the same database inside the area. See, for example, if area 1, right, all the area 1 routers should have the same database. All the area 2 routers should have the same database. All the area 3 routers should have the same database. Area 1 and area 2 should not be in the same database. That will be different. Okay. If it is in area 1, inside the area 1, area 2, area 3, 1, 2, area 1, area 2, area 3, all the routers inside this area should have the same database. Same database, same database. But area 1, area 2 cannot be in the same database. That will be two different things. Okay, that is one thing you have to remember now. Now we saw the OSPF downstate initialization two-way state. In exstart state, right? So what is the OSPF thumb rule? Every router should have the same database, correct? That is the OSPF thumb rule. Inside the area, every router should have the same database. Okay. So what will happen here? Now exstart state. In exstart state, it's going to decide which router is going to send the database description packet, whether R1 has to send or R2 has to send. Okay. In exstart state, okay, which router, so R1 state, which router decides, okay, or which router decides who has to start the exchange of database descriptive. Which router has to start exchanging the database descriptive. So how the database descriptive is, it's nothing but, for example, see here, this router has to send the, so see how to say, okay, this router is so going to send the DBD. You will see in the white shark capture. This is D, guys, D, database descriptive. Okay, similarly, R2 also send the database descriptive. Database descriptive packet will be sending it. But here, there is an election will happen who has to start exchange the database descriptive first of all. That is what in the exchange state, we'll discuss these two things simultaneously. In exstart state, the election will happen. Election for what? Who has to start exchanging the database first? Whether R1 has to send or R2 has to send. They has to election. Okay. So as I told you, OSPF should have the same database. So here the election will happen on extra state, which router has to send the database descriptive packet. Okay. So both the routers will be sending, this router will be sending database descriptive and telling, so I'm going to start the exchange. This router will sending database descriptive and tell I'm going to start the exchange. But it's not like that. There is some criteria to elect the database descriptive. Okay, so there is some criteria to start exchanging of the database. Okay, database is, what do you mean by database, guys? Database is nothing but the prefix information. What are the prefixes contains on this router? We have to, 1.1.1 and 1.100. Here in R2 we have prefix information 1.1.2, 2.2.1. So this guy will send the, see, that is what I told you, right? What do you mean by link state routing protocol? So link state routing protocol will send the what? Will send the link information to the R1. So what is the link? That is what Trimlesh asked, right? So what does the link information carries? It is going to carry the prefix information 1.1.1 and 2.2.1. So if you look into the OSPF database, right? If you look into the OSPF database, this is the OSPF database of R1. So what is there? This is my link ID. Okay, so if you see this link ID, right? So what is my link ID? For R1, He's sending 1.1.1 and 2.2.1. Okay. So that is what it is telling here. Okay. So who is my advertising router here? 1.1.100. Okay. So this is the link ID of, see, R1 1.1.1.100 and 2.2.2.100. So 1.1.100, what is my advertising router? This guy. And 2.2.2.2, what is my advertising router? See, 2.2.2. See, guys, if you understand this thing, Tirumalesh, you asked me one question, right? When we talk about distance vector and distance vector and link state routing protocol. Hello?
Yes, Satya.
Okay.
Yes,
If
Satya.
you see this carefully, see, 1.1.1.1. Who is advertising this 1.1.1 network? Okay, which is coming from, this router. Okay, and 2.2. Where it is connected? 2.2.2. It is coming from 3. Okay, so okay, so if you see this, who sent this 2.2.2? See, from anyhow, which is coming from R2 to R1, right? So that
Yes,
is why
Satya.
this is the new link state. New link states means in area 0. See, this is you have router link states and new link states. Okay, so router link states, which 2.2.1. Okay, this is your 2.2.1. Who is advertising? This R2 is advertising. So that is why it's router link state. Because this is one router, this is one router, these two are connected, directly connected. So this is the router link states and 1.100. So this is my 1.100 and 3.100. Okay, this is the 3.100. See, this is and moreover, every routers will have the same database. How it is connected? No, this is the same database on every routers. If you see here, right, that will also will be same database. Show IP OSPF database. Okay, see. Two to 100, everything will be have the same database. Now here, let's come back to the xstart state. In xstart state, what will happen? Since all the routers should have the same database, okay, R1 and R2 should have the same database. So which router has to start exchange the database first, whether R1 has to send or R2 has to send? That election will happen in xstart state. So based on the criteria, so based on the what criteria? Based on the router ID. Router ID is something which manually configure it. Okay. And next is loopback address. If you configure the loopback address, right? Loopback address and highest active physical interface IP. Okay. So to which router has to start exchange the database, right? It has to go some election process. That election process, and first of all, what is the first criteria? Router ID. Router ID. Second one is loopback. Third one is physical IP. Okay. So router ID is something that we manually configure it. Okay. So or loopback also we should have the loopback. Okay. So physical interface IP, this IP address which will take it. Okay. So which one is higher? That one will prefer. Okay. Let's see. Yeah.
Here loopback means what?
Loopback is something that it's like a virtual interface.
Sure.
Okay. So we haven't configured the loopback yet. Okay. It's something like a virtual interface that we'll be configuring it on the routers. Okay, now R3. Okay, so now if you see here, R1 and R2, right? This is two-way state. After two-way communication which happened, right? See, who is my neighbor? 2.2.1 is my neighbor. Database exchange is happening. Send database descriptive. See, your R1 router is sending database descriptive 2221 with a sequence number. Okay. And it's better you can see in the wide shot capture. Yeah. So first we receive the hello packet sent from R1 to R2. R1 router IP address is 1.1.1 and it is going via multicast IP address of 224.0.0.5. Okay. And R2 router has sent the R2 router also send the IP address. I mean R2 router also send the multicast what is that hello packet. Okay, that's fine. Now after sending the hello packet, right? So R1 R2 send and after that initialization state. Okay, and two-way state. Now in extra state. In extra state, what will happen now? See, your R2 router send the database descriptive packet. Okay, and your R1 also send the database descriptive packet, and R1 R2 has send the database descriptive packet. Okay, so here 1.1.1 and 1.1.1.2. Okay. If you see this one here, database descriptive packet. So what I told you, which router which is having these parameters like router ID or loopback ID or physical interface IP, which router is having either any one. So since we not configure the router ID, it will go and check with the loopback. If we not configure the loopback, it will go check with the highest physical interface IP. Okay. If you see this one, right? Okay, see carefully, guys. This is the database descriptive packet. I'm opening this packet. Okay, so I have a sequence number of 4337. And if you see this one right here, you can see not this information is not required. Four three three seven. Okay, so if you see this one right, so first of all, you have this R2 send the database descriptive, guys. What? R2 send the database descriptive. See this R2 send the database descriptive to R1 stating that I'm going to start exchange the database exchange. Okay, and after that R1, see when the R2's right, R2 1.1.2, when R2 send the database descriptive, if you see this one right, there is a sequence number of 3752. Okay, but if you see the what is the highest physical interface IP is configured on this one, 1.1.2 and 2.2.1. Okay, and if you see this one R1 right, on R1, okay, see first of all your R2 send the database descriptive packet. When it R2 is sending database descriptive packet, right? See what is the IP address? 2221. 2221 is nothing but this one, this interface IP. Okay, that is a source OSPF router IP. And R1 send the database descriptive packet with a source of 192.168.1.100. Okay, and with sequence number of 4337. So can you tell me now which router is having the highest IP address, R1 or R2? Rachit, see which IP address is bigger, 192.168.1.100 or 2221? So definitely 192.168.1.100 is bigger one. So that's the reason. If you see this one right, the sequence number of 4337, it will be the one which is having the highest, okay, highest IP address, right? That will be taken into the consideration, and that sequence number will be taken into consideration. Okay, 4337 and 4338. So now the R1 router wins the election process, and it's going to send the database descriptive packet to R1 to R2. Okay, that exchange will happen in the exchange state. So I'm repeating it again. So what will happen after two-way state, right? Extart state. In extart state, so R1 will send the database descriptor to R2. R2 will send the database descriptor to R1. Okay. So based on the election criteria, based on the router ID or loopback or physical IP, which one is having the highest one, that router will wins the election. And in exchange state, right, that router will start sending the database to R2. Once this guy send the database to R2, right, and R2 also send the database to R1. So if there is any configuration or prefixes are missing, right, then for example, let's see, R2 send the database to R1 and R1 send the database to R2 in exchange state. Okay, that will be in exchange state. Now in loading state, what will happen in loading? In loading state, both the routers should have the same database. Okay, so R2 send the database to R1, R1 send database to R2. Now there are some few configurations has been missing. Okay, this guy send the database to R2 send the database to R1, right? And R1 has his own database. It's going to verify, okay, whether everything is same or not. If it is not same, if any configuration is missing, right, then R1 will send the I'm requesting, so there are few information is missing, so can you give me that? So that is called the link state request. Link state request will packet will be given and it will be reply back with an update. Okay, you for example, in loading state, what will happen now? In loading state, all the routers should have the same database. Okay, so in exchange state, database sent from R1 to R2 and R2 to R1. Okay, once database is sent, right, R1 has his own database, so which contains 192 R1 has his own database which contains 1.100 and 1.1.1.1. Okay, and R2 has its own data. So we receive the database from R2 which contains some information. Okay, it's going to verify. Okay, and it's going to add it to a new database. If any configuration is missing, right, so there is some new prefix has been came here, but it's not validated, so R1 will send, okay, some prefixes information has been missing. Okay, so it sends the link state request. Okay, for example, this R1 is telling that 192.168 3.100 prefix is missing. 3.100 prefix is missing now. Then this guy will send the link state request for 3.100 is missing, and this guy will update it. Okay, and this guy will acknowledge. That is called a links. This is link state update. This is link state acknowledgement. Okay, that will be in loading state. And finally, full state. In full state, right, what will happen? Now both the routers, loading state will confirm. Loading state ensures that all the routers should have the same database. After loading, right, if both in loading state, it ensures that both the routers should have the same database. If it is not same database, then it's going to send the link state request for the prefixes which is missing, and peer routers will send the link state update, and this router will send the link state acknowledgement. After that, full state. In full state, what will happen? So it runs the SPF algorithm and finds the best path and put it in the routing table. I know that most of the people didn't understand because I went little deep in OSPF neighborship. Simple, guys, I'll tell you. Simple 7 steps. First of all, in down state, R1 and R2. R1 sends the hello message. There are some few parameters. Okay, when R2 also sent hello message. First of all, both the routers will be down state. Why both the routers in down state means R1 sends the hello message, R1 and R2 also send the hello message. Both the routers doesn't know about each of the peer routers, so that's when down state. And initialization state, both the routers receive the hello messages and it will have an entry in the neighbor table. That's why it's in an initialization state. And two-way routers, both the routers send and receive the hello messages and they are recognized each other and they are in two-way state. And extart state, in extart state, what will happen? It's going to start sending the database descriptive to elect which router has to exchange the database. Election will be happen based on the router ID. Okay, and loopback address and physical IP. Okay. And after that, so which router wins the election based on these criteria, that router will start exchange database. That will happen, exchanging of database will happen exchange state. After exchange state, right, there is a loading state. In loading state, it ensures that all the database of OSPF inside the OSPF area, they should have the same database. Okay. If database is not same, then the routers will send the link state request. Link state request, which contains if any prefixes are missing, right, that information will be there. Okay. So it sends that link state request, link state update, and link state acknowledgement will be happening in loading state. And after that, in full state, right, what will happen once database is all the routers inside the database should have the same database, right? Once database is fully converged, then on the database, it's going to run the SPF algorithm and finds the best path and put it in the routing table. That is what will happen. I'll give you the documentation, guys. Just go through with that. Okay. Any questions on this one? I think it took long time.
Satya, please send recording,
Nah.
revision will be.
Show IP. See, if you see show IP OSPF neighbors, right? This is the command. So R1 is neighbor with 2.2.1. Who is 2.2.1? This router. Okay. See this. So R2 is the neighbor with 1.100 and 3.100. Okay. So R3 is neighbor with 2.2.1. Okay. I'll share the recordings and I'll share the document as well. Okay. Go through this OSPF, guys. This is very, very important. This one OSPF, at least neighborship, if you understand well, that is enough. I'll give very simple documentation. You go through that. Okay. Any questions?
No, sir.
And try doing the lab. And the commands are only 2 commands. I hope everyone did make a note of it. Just do the lab, what I did right now. It's very simple. Lab is very simple for OSPF. And you see the basic lab, just to set up the neighborship, it's not a big task. Okay. So from R1 router, I can ping to 192.168.3.100. Why? Because I have a route exist here. Show IP route. Okay. See, there is something that we need to discuss it here. Okay. See, 110. What is 110 here? Hello? What is 110? Naveen? AD value. What is this 3? And if you see what is this 2 here? Metric. Cost. So how it is been calculating now? See, I'll tell you. If you want to reach 192.168.3.100, right? See, from R1 to R2, the metric is 1. From R2 to R1, the metric is 2. From R3 to to reach to this interface, right? Again, there is a cost of 1. So 1 plus 1, 2, 2 plus 1, 3. If you want to reach to 2.2. network, this is 1 and this is 1. Totally 2. 1 plus 1 is 2. That is what it is telling here. Got it?
Okay.
So this is your routing table, which contains, see, destination, see this one, destination network, okay, followed by subnet mask will be there, okay, and next hop, administrative distance and metric, okay. So if you want to reach 2, or if you want to reach 3. network, right, see, this is the destination network. Okay, routing table consists, I told you, the destination network, subnet mask, next hop to reach to the destination network, administrative distance and metric. Okay, guys, this is what your routing table consists of. Any doubts, please ask me. I'll share the recordings. That's all for today. So tomorrow we'll discuss a new concept in OSPF. Okay, guys.
Okay, sir.
Okay, sir.
Okay then. Avinash, all good, huh? ఏదో చేస్తున్నావు
టిఫిన్ చేస్తే
మ్యూట్ లో ఉన్నావు అవినాష్ నువ్వు యువర్ ఆన్ మ్యూట్
నా క్లాస్ వింటా వంట చేస్తున్నా అంటే
క్లాస్ వింటూ వంట చేయడం ఏంటరా
మమ్మీ లేదన్నా
ఇది చూపించి ఒకసారి వీడియో ఆన్ చేయి ఏం వంట చేస్తున్నావు ఇది చూపించి ఓడి అమ్మా ఓకే సరే see guys, Ashwini and Ashwini, Rachit, okay, see there are some openings are going on here, you know, at least the basics, that is enough. TCP, okay, fragmentation, keep preparing that, okay, TCP and fragmentation. I will refer you. All right,
Okay,
guys.
sir.
Okay.
refer me also అన్నా
I will refer you definitely. First of all, focus.
yes అన్నా
Okay, then bye bye, guys.
బాయ్